Welcome to the webinar on Prometheus. Well, we are going to talk about a lot of things, including Prometheus. So monitoring using Prometheus. Yeah, that's the topic that we are going to start today. And my name is Amit. And I'm going to be your discussion partner here. And today we are going to talk about basically, any application monitoring. Application monitoring using metrics. Okay, so we are going to talk about this topic. Yeah, this is the main thing that we want to learn. Now, again, it's going to be high level. 2 hours is not enough to even barely scratch the surface of what all things go into the monitoring. But yeah, this is what we are going to do. Yeah. So subtopics. Oh, sorry, I am not sharing my screen. Looks like. Just give me a second. Do you see my screen now? All right, cool. Thank you for letting me know. Okay, so this is Amit, and we are going to talk about application monitoring using metrics. Yeah, we will talk about what is metrics, and then what is monitoring, and what do we do with metrics. Yeah, so we are going to cover all that stuff. We are going to talk about some specific tools. So we will have a kind of a 1-minute brush up on Docker, because this is an example that we are going to monitor. We are going to use C Advisor. So again, I'll talk about 1-minute introduction for these topics. Then I'm going to talk about Prometheus, right? This is the focus. And in Prometheus, we are going to talk about the architecture. We're going to talk about installation, right? We will also take a look at various components. Then we are going to have a demonstration, right? We will, if time permits, we will also talk about Grafana, and then have a demonstration on Grafana. So we are going to understand Grafana. We are going to integrate it with Prometheus. Integration with Prometheus. And then we are going to have a demo. That's the agenda for today. All right. And what I'm going to do is I'm going to break for Q&A here. So you can ask your questions once we finish Prometheus. And then at the end of the session, we will also have Q&A. Right. So please note that this is a webinar. We may not be possible. It's not possible to have a detailed technical discussion here, right? So it's just an informational webinar, and I think SkillUpRight is going to set up more webinars in future for more technical insights. Okay, so our expectations should be aligned with that. Okay, so let's talk about metrics first. Let's start with metrics. What is metrics? Yeah, so metrics is a plural, right? So the plural is metric, and sorry, singular is metric, plural is metrics, or matrices, sometimes also called as matrices. Okay, now what are these? These are some sort of insights or measurements that you can take about your applications, right? Now, what kind of insights? Give me an example. Let's say this is your web application, right? Users are able to access the web application if they go to http myapp.com, they get this some web application here, right, in the browser. Okay, now there are a lot of informational data that you can capture about this interaction, right? So this is a browser, this is a user who is accessing the application on the browser, and then here is the server, right? Here is the server where the actual application is running, right? So this is your application server, and this application is accessed from this browser, right? HTTP or HTTPS. Okay, now the user experiences your application, and it also experiences the performance of your application, right? For example, is the website loading slowly or it's fast, right? How much is the latency? What if I run some compute intentional tasks? So what is the performance? Right, so all these are some parameters which a user's experience will be based on, right? If you go to website, I'm not sure how many of you are from India here, but if you remember around 5-6 years back when Indian Railways launched their booking application, booking websites called as IRCTC, well, it was the most hated website in India, right? So it wouldn't load, it would take ages to process the transactions, your transactions may time out as well. So that was some experience that was experienced by the users, and these are the criteria where the users will generally, you know, subconsciously measure it. So performance is bad, latency is bad, the website is very slow, the behavior is not correct, and things like that. So this is a perceived measurement of the application. But as an administrator of the application, let's say you are responsible for the web application, this is an admin or the development team, whoever, and they want to get some concrete data about what is the application performance, right? What is the user experiencing from this application. They cannot ask the users for these concrete data. If they reach out to the users that, hey, can you tell me what is the performance of the application, the users will say it's very slow. Yeah, that's not enough for the developers or for administrators. So how do they get some concrete engineering data to maybe, you know, increase the performance or whatever is desired? So for that, what the administrators or developers or actually application responsible people, I will say app responsible. So what these guys will do is these guys will extract that information from the application itself, right? So they are going to write their application. So the application code runs in the server, right? This is your application. So this application code is going to capture all the measurements, all the parameters that may indicate its performance. For example, it can capture how much time it is taking to serve one HTTP request, right? So time to serve, right? And also how many timeouts have happened in the application, or how many users are accessing the application, right? How many times a particular database has been accessed. So all these are some concrete, valid data points which this application responsible person can make sense of, and then can say, all right, I see that there are a lot of timeouts, so maybe let's target that, let's optimize our application so that the timeouts reduce. And then I see there are a lot of users accessing and we have only one instance of application running, so maybe we add more infrastructure, we add more compute power so that we can satisfy those users, and maybe that approach can also reduce the timeouts, right? So all these become valid data inputs for the application responsible people. These are called metrics. Okay, and the metrics gives you insight about an application. So it's kind of a measurement of your application's performance, right? Now, generating metrics is application's responsibility. So application has to generate the metrics. App should generate metrics. It is application's responsibility. So the developers should enable this. So developers should enable the applications to expose any metrics, right? If your application exposes the metrics, it's the application. So let me put it this way: the approach or the method of enabling an application to generate the metrics is called instrumentation. Instrumentation. Just give me a second. Yeah, this app crashed. 1 minute, please. All right, so instrumentation. If your application is instrumented, that means it is generating metrics. If your application is not instrumented, that means it's not generating metrics. Okay, now how do you instrumentation? We will talk about it when we talk about Prometheus, because the instrumentation is very specific to what tool you are using. So we'll come back to that. But this is essentially what metrics is, right? So now there are many kinds of matrices, but mostly there are 4, which actually Prometheus talks about. So there is gauge, right? There is counter. Let's take a look at official documentation. Prometheus metrics types, right? So there is counter, there is gauge, there is histogram, and then there is summary. These are 4 types of measurements. Okay, so counter is nothing but a cumulative matrix that represents a single increasing counter. For example, for how long your application is up, right? So let's say your application started on Monday 2 p.m. That's when you deployed your application, right? So then there is a matrix called uptime, for how long the application has been running, right? If you check at Monday 2 a.m., it will say it has been running for 12 hours, right? If you check it on Tuesday 2 p.m., it will say it's running for 24 hours, right? So it's going to increase the value of this metric is going to be increasing based on the time. It will never go down. So the counters always increase. Or for example, another is total number of users served or total HTTP requests served, right? So it can never go down because it's a cumulative number. In last 1 hour, we have served, let's say 10 requests, then 5 more came, so total 15 requests, then 5 more came, total 20 requests. So at different points of time, you will get different values, but they are going to be increasing always. So such a matrix is called a counter. Okay. Then let's take another example, which is gauge. Gauge is a matrix that represents a single numerical value that can arbitrarily go up and down. For example, let's say what is the current memory usage? What is the current RAM utilized by this application? In case of Java, you can say what is the heap size of the application, right? At any point of time, it's going to be one number. So let's say the heap size of the application at Monday 2 p.m. is 500 MB. Then later, based on the load on the application, it can go up 700 MB. When the load subsides, it can go down 200 MB, right? So at any point of time, you will get a particular value which is valid only for that time, and it can go up or go down, right? So it is a gauge. So this is one metric type, right? Histogram. The histogram is, it samples observation and counts them in configurable buckets. It also provides sum of all observation values. So a histogram is like, for example, it's a bit of a histogram. Yeah. So histogram means over 5 minutes, over the last 5 minutes, what has been the RAM utilization. So for last 5 minutes, what's the RAM utilization? So you will get set of values. So during the 0 minute, the RAM utilization was 300 MB. Then the first minute RAM utilization was 100. Then second minute 400, third minute 50, something like that. So you get a set of values. This is called a histogram. You get a set of values. Okay, a set of values is called histogram. Where did it go then? Finally, there is something called a summary. Right? And with summary, you can do some sort of operations. There is something called a summary. Okay, so summary also gives you a set of values. So for example, in last 5 minutes, what has been the RAM utilization? And you can get set of values like 300, 100, 400, 50, and 70. Let's say this is a set. But then you can also run some computation on this. So you can say, give me the average of this, give me the total sum of this, or give me the mean of this, or give me the max or minimum of this value. So you can kind of derive some further metrics out of this. So these are 4 types of metrics. Okay, now you don't need to remember them as of now. It's just sufficient to understand this. And for our examples, we are going to see some example of this and some examples of this. Okay, all right. So these are metrics. Okay, now what we are going to do is, before understanding Prometheus and metrics and all that, let's generate some metrics. Okay, so what I'm going to do is, I'm going to create on AWS. Now you don't need to know AWS. I'm just going to create 2 virtual machines. Let's not mention AWS here. I will have 2 VMs. Okay, this is going to be VM1 and this is going to be VM2. I'm going to have 2 VMs, and on the first VM, I'm going to run Docker. So some Docker containers. I'll start some Docker containers. These are Docker containers, right? Then I'm going to install an application which is called as cAdvisor. Yeah, so this is cAdvisor. C stands for container, so container advisor. Now this web application, what it does is, it talks to Docker and it gets complete information about how many containers are running, how much resources containers are utilizing on the system, and things like that. And it takes that information and then exposes them as metrics. Okay, so we are going to first talk about this. Let's generate some metrics. Okay, now this can be natively done by some web application. So on some other VM, let's say there could be a web application running, web app, right? Any web app, and you can generate some metrics out of it. So I don't have a web app, so I just want to show you how we can have this thing done. Just give me 1 second. Yeah, all right. Okay, so we are going to do this first. Okay, so let's get a couple of machines. Let me log into my AWS account. I'm going to pause my screen for a brief moment. I resume my screen. Let's create 2 virtual machines. All right, I'm just creating this and I'll create 2 instances. And my instances are created. So first I'll call it as C advisor. And second one will be called as, let's say, Prometheus. So my instances are now up and running, right? So let's connect to first instance. The first instance has this public IP address. I'm going to open my terminal and I'll say SSH. Done. I'm connected to this machine. This is my Docker machine. Okay, I'm going to quickly do apt update. Done, and I'll say install Docker. Run. Done. Okay. Now let's say Docker run -d nginx. So I'll just run an image, run a container based on Docker. Okay, and I will also run another container like based on HTTPD. So I'll just run 2 containers here. If you have not worked with Docker before, so you can watch previous recordings or previous webinars that I did with SkillUpRight. So I talked about Docker in detail, but you can also read more about it over the internet. Docker also has good documentation. So this command should make sense later on. Essentially what I'm doing is I'm running a pretty standard container based on HTTPD image here and based on Nginx image here. So these are going to run some applications. What application they run, we don't care. We just want to ensure that 2 containers are running. What is running in the container is not important, but we just want 2 containers. Okay, so 2 containers are running. You can see here our 2 containers are up, right? So I created 2 containers. That's the first step. Second step is to have cAdvisor. Okay, so I'm going to, let's say, let's install Docker Compose. Now we are going to use Docker Compose to install our cAdvisor. Okay, what Docker Compose does is it gives a recipe to install multiple containers at once. And since cAdvisor requires multiple containers or multiple application components, so we are just going to use Docker Compose. Again, we don't need to understand how it is installed or what are the nitty-gritty and details about how it is installed. We just want to have it there, right? So cAdvisor installation Ubuntu. cAdvisor. Maybe I'll just say cAdvisor. Yes. Yeah, here. Okay, so what I'm going to do is this is my YAML file. No, we are not looking for that. So this is a YAML file. And I'm going to connect to my container here or VM here. I'm just going to say this is my YAML, pretty standard. What's going to do is it's going to run 3 containers. It's going to run a Prometheus. We don't want Prometheus, so I'll just remove it. All right, so I just want to run cAdvisor and read this. I'll save it. Then I say sudo docker compose home.yaml. Sudo docker compose sorry, yeah, I need to do this -f -d up. Docker compose -f. Okay, let's say up -d. All right, so now you see everything will be start running in a few minutes. All right, so our cAdvisor is running and Redis is running. If I say sudo docker ps, I will see the cAdvisor running and also Redis is running. Now we don't care what these containers are doing at all. So what we want is we want to access this application, SeeAdvisor application. Yeah, so I can access this application on port 8080. So let's go to this public IP address of this virtual machine. And if I go to port 8080, hopefully I will see SeeAdvisor. Right, so my SeeAdvisor is running here, and this is some information about Docker. This is fine, but over the time, you can see some graphs generated. So how much total memory is being used by Docker? How much is the usage per core, total CPU usage? So all that is being captured here, right? And if I run some more containers, this will definitely go up, right? So I can say maybe I'm running one more container for MySQL. And if you observe here, once the container will start, okay, my MySQL container is not running. I think I gave incorrect password. Just give me a second. I need to provide some environment variable, right? Yeah, MySQL allow empty password. This is the variable. And now we see MySQL is also running, and hopefully it is also taking some resources. Yeah, unfortunately, not much resource utilization. I cannot generate much of resource utilization. Yeah, anyways. Yeah, so as you can see, whatever resources are being utilized are being captured by SeeAdvisor. And this is for your Docker containers. So there is a question, is it the metrics about the VM or individual containers? It's only about containers, right? All the containers together. Okay, all containers together. So you can see there is MySQL, and there will be other things also here. So you can see maybe container names also. You can see here, total CPU usage for all the containers, memory usage, it is a bit there. Yeah, so 750 MB is being used. So yeah, you can see here the containers, right? Okay, so now what I'm going to do is I'm going to now, this is the metrics. Yeah, these are the metrics here. You can see it. You can show it to other people also, that this is the total resource utilization for your system, right? But then there are no metrics generated which I can actually capture and say, all right, how my containers are working. How can I capture the individual metrics? So the individual metrics are available on So maybe if I say, yeah, this is the containers. Just give me a second. Maybe I should. Yeah, so here if I go to this specific URL, which is metrics. So on my CAdvisor application, if I go to metrics, you can see these are the actual metrics generators. These are the metrics that can be captured by a developer or an administrator, and then these can be used to assess the performance of the application. Right, this is a web GUI which is good to see and good to demonstrate to your end users and things like that. Yeah, so that they can make sense out of it. But this is what engineers will love. They are going to capture this and do some better things with this raw data. Right, so these are the metrics. Right, for example, let me find out easier metrics to start with. Again, these are very complex metrics, so just give me a second. I zoomed it and there is so much data that it's not zooming properly. Let's load again. Just let me find out something which can make sense to you. This is inodes. Yeah, okay. So for example, there is this metric here, this one. This is a counter, okay? And it has a helpful comment also. So the text is a bit small. Maybe I'll just copy it somewhere. Or I'll do this. I'll copy all these ones and put it on Notepad. Okay, so this is a snippet of the metrics. So here you can see, for example, there is this gauge matrix called machine scrape error. Yeah, and here is some help comment here. Help says that this is a metric. It will be set to 1 if there was an error while getting machine metrics, 0 otherwise. So the value is currently 0. That means the machine is being able to generate metrics successfully. So there has not been any error. Then there is this counter. Yeah, this process CPU seconds total. This is a counter. And this talks about total user and system CPU time spent in second. So here is 38 second is total CPU time spent for user and system mode. Right? There is also, for example, how many virtual memory bytes are used. How much is the start time in seconds? Yeah. So, for example, this is a counter. So when I checked last time, the counter value was 38.48. Now, since this is a counter, the value will only go up, right? So if I refresh this page, if I go to end, You see here, process CPU seconds total, it becomes 54.06. So it's going to, the value is going up. Right here also there is a gauge which says process open file descriptors. That means how many files are opened by the containers. Here it is 29. If I refresh, it may change. It may go up, it may go down. Maybe I will start one more container and it may go up as well. So let's start one more container. Like this maybe. Yeah. And if I refresh this is still 29, but maybe later it can come up also. Yeah, it's still 29. But yeah. So this is the total metrics. So can you guys see the metrics here? Saktivel, maybe you should check your network because I'm sharing the metrics. Maybe there's a delay on your system. All right, so these are metrics. Okay. Now, what do we do with these metrics? We are able to generate the metrics. So the next thing is do something meaningful with this metrics, right? Now, to do something meaningful, what we do is we use a tool called Prometheus. Okay, Prometheus. Yes. What Prometheus does is it is actually a storage for metrics. Well, it's actually not storage, it is a scraper and storage. Scraper and storage for metrics. So what it does is we configure Prometheus to, so okay, maybe I'll show like this. There are two major components, three components. Yeah, there is a scraper, then there is a database. This is called as time series database, so I'll talk about that. And then there is a web interface. Okay, three main things for Prometheus. Now, what scraper does is, so we define some configuration here. And in the configuration, we specify that we want to scrape some metrics from somewhere. Right? So we'll say this is our scraping target. We specify a target. It may be something like as a C advisor or some application, whatever. And the scraper will now, based on this configuration, it will talk to the target. Maybe it is C advisor. And then it will download all the metrics from there. So whatever we saw, it will download them and it will store them in a database. Okay, so every X amount of seconds, so maybe by default it is like every 10 seconds or 15 seconds, the scraper is going to talk to the C advisor and download the metrics data. Then again after 10 seconds, talk to C advisor, download the metrics data, and it will save it. So there will be snapshot of metrics. Every 10 seconds, there will be a snapshot of metrics created. Okay, so with default instrumentation like C advisor, we get metrics at point of time. So these metrics are in point of time. You cannot access past matrices like what was the metrics 10 days back. You cannot access that. So with Prometheus, it scrapes the data, stores in the database, and you can access historical matrices also. Okay, that's the purpose of Prometheus. And then you can access this data. So it is also exposed by a web interface with web APIs. So you can use this data to create some historical visualizations. So we'll come back to that. Okay, so now what I'm going to do is in my second VM, I'm going to install Prometheus. Yeah, and the Prometheus is going to be configured so that it talks to our CAdvisor metrics and stores them in the database. Okay, let's do that, and then I'll open for questions. So let's connect to the other machine here. This is a second machine where I'm going to install Prometheus. All right, so what I'm going to do is we will quickly bring up Prometheus. So first I'm going to create a Prometheus.yaml. And I'll take you through what Prometheus.yaml does. But for now, let's just create it. So from this machine, on this port, CAdvisor is running. So I'll just give that information. Okay, sudo docker compose -f/tmp compose YAML up -d. Okay, Prometheus is up, right? I have installed Prometheus. So if I get the public IP address, and if I go here and go to 9090, for example, you will see Prometheus is up, right? And to Prometheus, when I created Prometheus, I passed on this Prometheus.yaml. Prometheus.yaml. And in the Prometheus.yaml, I specified that we need to scrape a metrics. And okay, this is a configuration to scrape. Let's call this scraping as CAdvisor. And where to scrape from? Scrape from this host name and this port. This :port 8080. This is where my metrics are available. So Prometheus should now talk to this URL and get my metrics. Okay, so this is Prometheus. And there are a lot of things here. This is the home page. We'll come back to this. But what happens is if I go to status and if I see configurations, or if I see targets, for example, you will see that there is CAdvisor target. right? And in the C advisor, it is getting all these metrics from this URL endpoint, which is nothing but this itself, right? So it is collecting metrics from here. Yeah, this URL is valid internally for this. These are not a public URL, so you cannot access it, but it's essentially this only, right? So it has captured some metrics. It has started capturing metrics here. And if we go to configuration, you can see that it is capturing C advisor. It is going to capture it every 5 seconds. So it will scrape the metrics every 5 seconds using HTTP protocols. Okay. All right. Now let's go to Prometheus here again. And here you can look for any metrics that Prometheus has captured. For example, I may look for this one, process CPU seconds total. So let's search for that metrics, press execute, and you will see that this is a metrics available and this is a value of 85. So we can see all these matrices, right? You can also see it graphically. You can see the historical data also. And you can see here that Prometheus started scraping the data at this particular point of time. And since then, the value has increased this much. So here the value was, what was the value? 79.79. And then it became 80.2. Then now it is, should be 85, right? Yeah, 85. Then it became 83, then 84, then 85. So you see the value is increasing. We can also take a look at some other metrics, for example, open FTs. Now this value can come up and come down. Let's see what is the value now. And it was 23, then it became 27, and now it is running as 27. So any changes here will also be available here. So let's maybe kill a couple of containers from the first machine here. So I'll say sudo docker rm-f. I will kill my MySQL server, both MySQL servers. What am I doing? Sudo docker rm-f. And with this, maybe the metrics would change here. Yeah, so I'm not sure if it's going to change. It's going to stay same. Yeah, I just tried something. Maybe I'll see this. Let's see this one, resident memory bytes. And this is going up and down, right? I just killed the container, so memory utilization went down. It was around 170 MB. Now it is 137 MB. Okay. So yeah, so this is how you can see now historical metrics. And now developers can look at this and say, all right, all the containers on this application, well, looks like something happened and the resource utilization went down. Or they can see the resource utilization going up and say, all right, there is some problem. The containers are using more and more memory. So maybe we need to take some action. Yeah. So this is what Prometheus does, and this is what the entire thing is all about. Any questions before we move on to the next topic? Can we set multiple targets? Of course, yes. So if I go to the VM, sorry, the YAML here for Prometheus, this YAML is a list of targets, right? So YAML is a list of targets. There is just one target here. You can add more targets for sure. How to configure external storage for Prometheus? So you can, by default, Prometheus stores the data in, there is a local database created called TSDB. But what you can do is you can create an external database which has different storage at the backend and submit your data there. So for example, by default, the database is within the application, but you can set up the database somewhere else, and then the scraper can store the data here instead of storing it here. How are the search words taken? And can I extract information from application logs? No, logs are not supported here. For logs, you have to look for some other big data solution like ELK or Datadog or something like that. How are the search words taken? So search words are generally, so it's called PromQL. Now, we don't have enough time to look at that, but PromQL is a query language for Prometheus. Right? And you can write what you want to query by following the PromQL. Right? So for example, you can select a particular metrics, or you can select a particular metrics for a particular job, a particular target. Right? So you can run your queries like this. Okay. Target here is server where metrics are captured, or target is the application server for which we need to see metrics. I don't understand the question. Both options sound similar to me, but the target is the application. Yeah, it's not the server. Target is the application which is running on this port. How to configure external DB in Prometheus? Okay, so that question can easily be answered by Google. If you know Prometheus, you can answer it. So Prometheus external database. Yeah, so if you go to storage Prometheus, so by default it uses local storage. Yeah, and in the .data folder, the complete TSDB data or time series database is stored. Okay, so what you can do is you can remotely connect to other storages. Right, so it works with open metrics format. Right, so you can, for example, you can store it in app optics, you can store the data in Grafana Mimir or Open TSDB. This is quite popular, right? So you can get some data there as well. Right, so here, this is how you can integrate. I cannot go into much detail here, but you can see here in Prometheus configuration, you can perform remote write and remote read as well. But again, how to set up this database, that is something that you will have to do. Can we create metrics as per our requirement? Absolutely. That's what is called instrumentation. Right? The application should produce a metric. So you can write any metrics that you want to capture and generate. How it's different with Elasticsearch, Kibana, and Logstash. So ELK works on log entries, log data. They don't work on metrics. Can be targets added dynamically, or it should be part of YAML file? It is generally part of YAML file only. So you have to capture specific targets. But again, if your app servers are dynamic, then you can maybe have a load balancer and generate the metrics from load balancer itself, gather from load balancer itself. So yeah, you should go that way. Can we expose JMX metrics for a Java application? I think Java applications, yes, you can. For example, when I talked about instrumentation, right? So Prometheus instrumentation, you can instrument a Java application to generate metrics, right? So if you want to instrument, there are all these languages are supported. Let's say we want to instrument Java. So I click on Java, and here is example, right? So you just have to define the dependencies, the library dependencies for Java, and then in your Java code, you just import the Prometheus library and generate your metrics. That's all. Okay. So you can, I think, expose JMX as well. Is it possible to capture metrics from a particular container only? No, but you can see the metrics from a particular container only. Yeah, you can filter out your results for a specific container. That can be done. I think somewhere here there is that. Yeah, maybe we can explore which metric is for specific containers. Yeah, but you can filter it out. I have microservices running on Kubernetes. How can I capture metrics to provide to Kubernetes? So Kubernetes works very nicely with Prometheus. So Kubernetes metrics Prometheus. Yeah, it is. So you can generate metrics in Kubernetes very nicely. Yeah. So I think you have to install a metric server, Kubernetes metric server, and then it works. There are some guides also. So there is this Prometheus, Prometheus server. So Prometheus servers, Prometheus talks to the Kubernetes service discovery and can connect from it. Let's see how we do it. Okay, so you create something called as a role and role binding. Yeah, then define some configurations. So if you install Prometheus on a local system, right, then you can, let's see, Prometheus deployment YAML. There must be some Prometheus configuration that they explain some. Yeah. Kubernetes API server. Yeah. So you have to define the targets. This is scrape config. Kubernetes nodes. This is a scrape config. Yeah, and it extracts from Kubernetes itself. So if you deploy Prometheus on Kubernetes cluster itself, it can automatically use the Kubernetes service discovery and show you the complete parameters. Okay. Can we customize our dashboard for particular application? Yeah, we will see that. For that, we will use Grafana. Can we configure specific application endpoints to check service level utilization? If it is a metrics, if you can export it as a metrics, we can do that. For Prometheus, CAdvisor install is mandatory, not required. CAdvisor is one of the targets that we set up. You can scrape CAdvisor, you can scrape normal applications if they're instrumented, you can scrape Jenkins, you can scrape Kubernetes, everything. The data script is stored in a database. How long will the data be retained? It is a local storage and it will be retained till you have the local instance. That's why you should always use external database, and the data retention depends on your database policy. If your database will be alive for hundreds of years, then the data will also continue to stay. There is no policy enforced by Prometheus. How about monitoring Fargate based containers? So for that, you need to, again, the best solution is if you are using ECS or EKS, deploy your Prometheus application on that particular EKS or ECS, and it can automatically then connect to the Kubernetes service discovery and get the information about all the nodes and all the pods. If you need to have a hands-on installing and expose metrics to Prometheus from EKS or Node.js container, what's the best way to start? Set up your own application, a small application, and then explore it here. Yeah. What changes I have to make in my Spring Boot application? So go through this guide, instrumentation guide. I don't know where did it go. So Prometheus, Spring Boot. You can generate Spring metrics like this. It's very easy. Okay. So go through this. All right. So let's take a quick 10 minutes break. And after the break, we are going to see how do we create much more useful visualization than just this one. Right? So this is a visualization which has very limited capabilities, but then we are going to create some nice, beautiful utilization as well. Okay, so let's be back in 10 minutes. And after 10 minutes, we are going to continue the discussion about visualization. See you in 10. All right. Hello, everyone. So let's get back to our discussion. So we see here Prometheus can get the data from the metric servers or metrics endpoints and can store them on the local system, right? So you can see the data being captured over time and then displayed over time like this. But again, this is just a very rudimentary visualization of data, right? How can we get some more engaging and more exploratory visualizations, which can give a lot of insights in our system, right? So that's when we see that Prometheus has a lot of limitations, and that's when we can use external data visualization tools. So external visualization tools, right? So we can visualize the data by installing a visualization tool, for example, Grafana. And then we can configure Grafana to read the data actually from Prometheus. So Prometheus has a web interface or an API interface, which allows other tools to read the data. So Grafana can read the data from Prometheus. And then here you can generate some nice pie charts, some histograms, yeah, some line graphs. So you can generate any kind of data here. Okay, so let's do that. Let's go to our system here and let's run Grafana. Okay, so I'm going to run Grafana in Docker container as well. So let's quickly say Grafana Docker. And just like this, I can do that. So on the same machine where I have Prometheus, I have installed Grafana, but that's not a necessity. You can install Prometheus on a separate machine and Grafana as a separate machine. It should work. Okay, so Grafana is installed. Let's browse to the public IP and port 3000. I think it is 3000. Yes. So you see Grafana in the title. So Grafana is up. The default username password is admin. We come here. We don't want to change the password, so I'll skip it. And this is Grafana for us. Right now, if I have to make some, for example, some visualization, what I can do is I can say that let's create a new dashboard. Okay, so this is a dashboard where I can put my UI elements. So I say dashboards, create new dashboard, and I can add a new panel and I can display some data like that. Okay, this is an example data. So now I need to have a data source which I can display like that. Okay, so let's connect Grafana to, let's go to settings and let's go to data sources and let's connect Grafana to Prometheus. So I say add data source and the first option is Prometheus. So I'll click on that. Data source added. Then there will be a setting like where is the data source and things like that. So my Prometheus is working on local machine. So this should work fine. So localhost :9090. Localhost :9090. And there is no authentication. So no authentication provided. And that is all. I say save and test. It says data source updated, but it is not able to run it. Connection is refused. Okay, I wonder why. 9090. Or what I'm going to do is, let's say this one. Yeah, so here with this it works. All right, and let's go back. So let's go to configuration and see data sources. Now data source is available. Now let's go back and create a dashboard. I created a new dashboard. I add a panel to it. And now this time I say the data source for my data is Prometheus. Yeah. And then I can select a metric. Okay. And the metric that I want to select is this one, because we have worked with this one. So I'll say this one. I'll select a metric like this. This is my metrics and run queries. And you see some data has come here. Right? And I say apply. So now in my dashboard, I created a panel for process, CPU, seconds total. So I can edit this also, edit the name. Yeah, this is the title. The process, CPU, seconds total. Yeah. And then I can also change how the visualization look like. For example, we can say transparent background or a gray background. So let's make it transparent. And then we can have some more things like lines should be like this or a bit curvy, or should it go like this? Yeah, so we can see now it's not very distinguishable, all these options, but you can define the line width, make it thicker, thinner. You can fill it so you have some more solid data to work with here. Yeah. You can also have, for example, like this. Yeah, I mean, it's all available. You can make the line as dashes. So you can have a really strong UI composition. So I save it, and then yeah, done. So my dashboard is now done, right? I can add more panel. So I can add, for example, another panel, and this time I look for another data. So let's say process open file descriptors. So I look for the query process open file descriptors, run the query. It goes like this. And here I can also modify. So I say title is this, and I can see where the accesses are and things like that. And the same things I can do like this, and line width can be made thicker. We can change the colors also, I'm sure. Yeah, let's make it points. We can show like this, we can show like this, and maybe something like this we can add. I'm not sure where is the color here, but yeah, we can find it. Yeah. So this is one more panel, 2 panels added to my dashboard. Yeah. Let's also say skill up, or let's say C advisor. And this is the dashboard here. My dashboard is saved, it's called C advisor, and these are the things here. Right? We can edit it again. No, let's remove it. Yeah, we can also zoom in, right? So we see, right, I want to see the data between 515 and 520. So I can just select this one and I can zoom in. Okay, so this is very, very powerful. And I can add more elements, more lines, more graphs, and then I can get a nice dashboard, and I can then display it. I can filter out for which container I want, for which information I want this. So yeah, but then there are so many options that you can spend a lot of time in setting up your visualization, and chances are somebody else in the industry, somebody else in the world has already created some nice dashboard which has all the required information, right? And they may also share the dashboard with other people so that they can reuse the dashboards. So Grafana allows people to share their dashboards. So if you go to dashboards, Grafana dashboards, yeah, you can see a lot of dashboards which are created by many users. Okay. Use dashboards. Okay, this is not the correct link. It's documentation about dashboards. Let's say here. Yeah, so this is the dashboards. Yeah, so here there are a lot of dashboards and you can use any dashboard that you want to import. For example, I want to look for a C advisor dashboard because I'm getting C advisor. So let's see if C advisor dashboard can show me some good data. Right, so is there any C advisor dashboard? There used to be, but let's see. Yeah, so here, this is a C advisor dashboard and it will create a dashboard like this for me. It will give me all this information. Nice, let's do it. So let's do this dashboard. So I'm going to copy the dashboard ID and in my Grafana, I say, let's import a dashboard. Let's import the dashboard. Yeah, discard all the changes. And here is the ID of the dashboard. I say load and this is the name. I say my C advisor should be the name. C advisor. And data source is Prometheus. Import. And now you see, based on my data, now a nice dashboard is created. There are some values which are not available. Maybe it will come later, or the metrics has changed and we need to update the dashboard. But here you can see how the dashboard is nicely reused from other people. Right? You can see here there are these containers running on my Docker. This is the memory utilized for containers. This is a graphical representation of those containers as well. Looks like this is the most memory intensive container, which is using 347 MB. Sharp Goldstein. Okay, so you can use Grafana to create some powerful visualizations, and you can generate these reports and then share it with your team or your management to tell them how this is working. Okay, and you can click on any panel and then edit it, and you can say, okay, I want to use this particular query or this particular query, and yeah, that should be customization. So let's see if I can get container count. Is there a container count? Yeah, I don't know. Okay, so yeah, that's how you can create your dashboards. Any questions on Grafana or on Prometheus? Now we can have a Q&A sessions, and then once we are done, we can wrap it up. How Grafana is connected to Prometheus, I showed this already. You can go to settings and go to configuration, or you can go to data sources here also. And I said, let's save this dashboard. Yeah, and if you go here and go to configurations, you will get this configuration page, and you can add data sources. So I added Prometheus. So you can click on add data source and then choose Prometheus and provide the username password if required. Can we take a look at Prometheus UI and its options a little bit more in detail? I suggest maybe you can install Prometheus on your own now that you have the complete information, and then explore it. How Grafana is launched. You have to install Grafana and then access it over the browser. Okay. Then can we have Grafana dashboard for a one microservice? You can create any dashboard. Yeah. So you can have a dashboard and then filter out all the matrices for your microservices and then just display those there. Metrics, gauge, count, summary, how and where to configure in app like CAdvisor. I'm not sure what you mean by configure. CAdvisor already generates these matrices, but when you create your own application, you instrument your own application and you want to generate a matrix, then you can instrument it accordingly. And during instrumentation, you can define what kind of metrics you want to generate. How to find the metrics? So metrics are generated by applications. So you should be able to, as a developer or as an administrator, you should know where the application is running and what metrics is being generated. Grafana and Prometheus should be in the same host? No, as I said before, you can have it in different hosts as well. Grafana is open source tool from internet. Yes, Grafana is open source. There is also enterprise version, but you can use open source also. Can Grafana be used to visualize logs from application? No, you cannot do that. For that, you need to have some log extraction service. Since CAdvisor already generating these metrics, can you show us where the logic is written in CAdvisor? No, unfortunately, I cannot, and that's not the scope of this discussion. You can go to CAdvisor code and see where it is implemented. Okay, so if you go to CAdvisor GitHub, yeah, you can go to this code and go through how the implementation is done. Yeah. Is Prometheus integration to New Relic as simple and easy like Grafana? I'm not really sure. I have never worked with New Relic. Maybe it is, maybe it is not. I'm really not sure. Sorry about that. Can we configure notifications if metric crosses threshold? Yes. So Prometheus can also have something called as alert manager. Yeah, so there's something called as alert manager, and it is also provided by the Prometheus organization itself. You can configure it along with Prometheus and define alerts. You can say if a threshold crosses certain value or reaches certain value or is lower than certain value, whatever, then send some alert. Okay. All right. Okay, so since no more questions are coming in, I really want to thank you guys for your patience, for your attention in the session. And I hope you guys enjoyed it. You guys understood something, at least. You guys get to take away something with you. And we'll meet next time. Yeah, maybe next month we will have one more webinar and we can meet here. Okay, thank you and take care. Bye-bye.